Hey everyone, and welcome to another video. In this one I'll show you how passkeys work, and especially how you can construct a smart wallet or build a smart wallet using a passkey authentications. Before I dive into the development, I'll show you a quick demo using Safe passkeys. So if you're not familiar, Safe is a big multi-sig wallet used by a lot of companies, but you can also leverage it to be your main smart account for end users. And then to be able to leverage passkeys, we implement WebAuthn. And WebAuthn is the standard that Passkeys uses, and Safe implements a module to actually verify the signatures of the passkeys. So it's a special module in that sense. So let me go through the demo very quickly. I'll hit create account here, and I'm using a security key actually on my laptop, and then I'll sign the security key, and this step actually creates the credential for my passkeys. And without making any on-chain transaction, I got a deterministic address that we can go see on the blocks, on Block Scout or on the Block Explorer, and it's nothing but an EOA address if you look on the Explorer, but it's actually this is the address where we're going to deploy the Safe smart account. So once I hit mint NFT right here, I'll sign a transaction using my passkeys, and here I'm using again my UB key, my security key in this example. And then I just submitted a transaction. The gas was sponsored by the sponsor here, Candide, and then we can go and track the user operation on the Block Explorer. And right here we actually deploy the Safe, and that Safe has the module enabled, the WebAuthn enabled as the owner of the Safe, and it can mint or make any further transaction if we want it for the next ones. Obviously you can see here I'm using a UB key, but you could, on iPhone you'll see the passkeys, let's say Face ID or biometrics. On Android you'll get this version, but the cool thing is that you can use it on different devices. After we've done our demo, we can go straight to the dev. So I'll go to the docs right here, and then we have a page called how to add support for passkey authentication. And what you need from this is, since the contracts and the module for the WebAuthn is already developed, it has been developed by the Safe team. There's also the audits and some formal verification of some pieces of the WebAuthn. You can go explore this on your own on their GitHub. They have plenty of information. They have a good README on how the contract works. But in this demo, we'll keep it straight to how you can actually add passkeys to your smart wallet. So what you'll need is abstraction kit, the library to create 47 smart wallets, and we'll also need a file called here WebAuthn that we can copy directly. This file essentially helps you interact or emulate the WebAuthn API by creating credentials and signing using passkeys. So I'll just copy it right here, and then we'll go into my dev environment. I'll create a file called webauthn.ts. I'll copy everything right here, and then we'll explore later on during this video what are these functions and how we can use it. I'll go back to the doc, and then the first step is actually to create the credentials. So you want to create the credential, ask the user, hey, do you want to create some credentials for this wallet or this website that you're using? So we'll go in and then we'll import the WebAuthn credential class from the file that we just copied. And then what's happening is that we're creating a new class on Navigator, and we're calling Navigator.credentials.create, and you're essentially passing this object right here. And I'll go through one by one what are these key and values in this object. So you have here a public key. So the public key has information for the relaying party, RP. The relaying party is usually your wallet. So right here we have it Candide. And then the ID is usually the domain. So right here we have candide.dev. Technically it should be passkeys.candide.dev if we're looking at this demo right here. And then the user, you could ask the user to provide a username, or you can have a random user ID. It doesn't matter in this case. Right here we're passing in the ID in a uint8 format, so that's why we're calling ethers.getBytes, and we're passing right here hardcoded Chuck Norris. We're passing the name in string, and then the display name, what you display to the user, their passkey name is Chuck Norris. The challenge is where you want to sign something. Use the challenge and tell the to WebAuthn or the user to sign it. Since we're not signing anything, so we're just gonna pass the date.now so that we can create credentials at the specific date. And then the public key credential parameters is essentially the algorithm you're going to be using to sign. It's always public key for passkeys. -7 is for the 256 algorithm, which is the curve that we're using to sign using WebAuthn, and then it's also built with the module. So I'll copy all this and then I'll paste it into my file. It's not gonna work out of the box because I need to adjust the imports, and we have everything ready. Now all we're missing, the next step, is to extract the public key from the create credentials that we just called. So once you create the credentials, we got the credentials from the user. Now let's extract the public key. And what is the public key in WebAuthn? It's actually just X and Y coordinates, and these X and Y coordinates, you can think of it as a mental model, like an X and Y on a plane, and these coordinates are specific, the X and Y are specific coordinates on that plane. So just copy this and paste it right here, and then obviously the import we need to adjust again. And WebAuthn public key is actually imported from abstraction kit, which is the type that we're looking at. Yes. And here to explain to you, so this function right here from the WebAuthn that we got, there's a function called extract public key, and extract public key essentially takes the response from the credentials and format it nicely so we can have an XY coordinates, so we can have it as an input to initialize our safe account. And then from there, the last step now is to initialize the safe account using the public key credential X and Y that we got. And then from there, we're actually gonna get a predeterministic smart address. So let's do smart account equal safe account. It's called v3 dot initialize new account, and then we'll pass in the X and Y coordinates right here, and then let's print the account address. We'll call it the safe account address. Now let's run this code, and voila, we actually got a safe account address from the WebAuthn public key credentials. And if we go to the block explorer, we'll see nothing is deployed because everything is just calculated. We didn't make a single RPC call using everything that we've done right here. And now we can go to the next step. Now the next step is actually to construct a user operation using our safe account. So let's do a transaction. So let's construct a regular call data transaction, meta transaction. So we define a meta transaction as the type of safe transaction, and it's going to have an object with a 2. So you can see here what is a meta transaction right here, just a 2, a value, and a data, and that's all we need to construct a regular transaction. So let's do an empty one. So for now, let's call the 0 address. The 0 address is imported from abstraction kit, and then let's do a value of 0. So we're not going to transfer any ETH. And then data, we're going to do 0x as nothing. So this basically doesn't do anything, but if we want to deploy the safe account, and our goal for this example, if we wanted to do a mint NFT, we could have added the mint address, the 0, and the call data to mint the NFT, and we could have done it in the same transaction, because it's always the user operation of a smart account always includes the deployment of the account and this extra transaction. Now let's do a user operation. I'll do let user operation because we're going to modify it later to add a payment step. We'll do await smart account dot create user op, the regular create user operation transaction, and then we'll pass meta transaction, and then we'll pass the RPC provider, and then the bundler URL. So I actually have them in my environmental variables. I do this quickly. And then to get a bundler URL, you just need to go to a bundler provider like Candide, and you get a bundler URL link, and then you can pass it in right here. And then we'll pass it in the node right here, and then I'll proceed the bundler URL. And then one thing that is new is that is not related to regular apps, is that you're gonna actually pass a signature pair, which we need to pass a WebAuthn dummy signature pair because it's much better for gas estimates. If you don't pass this information, you're gonna have worse gas estimates. And then obviously it's an array, because if you deploy an account or a multi-sig account with multiple owners, then you can add the different owners. So you can add an EOA owner on top of the WebAuthn, but we'll go into the multi-sig step later on. Now that we have created the user operation, we're going to add a paymaster step right here. And I got the paymaster URL from Candide's dashboard. And then I'll define the paymaster. So the userOp paymaster, userOp sponsored. And then we'll also get the sponsor metadata. And then we'll call paymaster.sponsor userOp and then we'll pass the user operation, we'll pass the bundler URL, and then that's it. That's all we need to sponsor this transaction. And then we'll replace our original user operation with the one that have the paymaster information included. And then the next steps is actually to sign over the userOp. So if you want to sign over the userOp, you need to get its hash first. So let's get hash to sign. So we're going to do safe account.get userOp p712 hash, and then we'll pass in the user operation and the chain ID. So the chain ID, I'm going to get it also from my env variables, which I defined already. And then let's actually do it as a separate variable. We're going to reuse it. And here I need to pass the user operation, and it needs to be big int. And now that I have the userOp hash, now I actually need to sign it. So let's see on the docs how we can sign this. So in order to sign in with Passkeys, you're going to actually use the method get. Get from our credentials essentially gives you the ability to get the credentials from the user that they already created and sign over our hash here that we're going to pass. So the challenge, as if you remember, when we did create the credentials, we passed in the date. But if you actually want to sign over a user operation or an intent to do a transaction, you pass it in the challenge in the format of uint8. So that's why we use ethers.getBytes here as well. The RIP ID, which is again our domain name that we're going to use. The allow credentials is again here the public key that we always going to use public key, and then you also pass in the raw ID. And then user verification, it means you actually need to require the signing or not. And in our case, when we're signing a transaction, we always need to sign required. So I'll copy this piece here, and then we'll import user verification required from the WebAuthn, which is a type right here. And you can see there's 3 types: required, preferred, discouraged. And these types are for regular web to auth, but if you want to actually sign a transaction, it needs to be required. And then here, this is our userOp hash that we're signing. Now after that we've signed over with the passkeys and we got the assertion from the user, now we actually need to format it so that we're able to submit this userOps to the bundler. So what we're going to do, we're going to add it in the same format as WebAuthn signature data, and I'll show you what is that format. That essentially takes in 3 key that are important: authentication data, the client data fields, and the RS, which is the signature, the RS signature that we need from the get credentials that we actually called. And then once we add it in, once we format and extract the WebAuthn signature, we can call safe account.create WebAuthn signature and pass in this format right here, and we're gonna actually get our signature, our signatures. So let's copy this. So these functions right here, they're all from our WebAuthn file, and extract signature the same, and WebAuthn signature data is actually from abstraction kit. This is just a type. Let me double check. It's misspelled right here. I have to spell it correctly. WebAuthn signature data, yes. And then we can call our safe account dot create WebAuthn signature, and when we're going to pass it in this format right here. So now that we have extracted the signature, now we need to actually format it to a userOp format. And the way to do it is through a signature pair. So we define the public key and its signature, and we pass in this signature pair to format it in a function called format userOp, format signature to userOp signatures. And then from there, we're actually going to get a formatted signature that it's with 47 account abstraction. So I'll go ahead and import our type from abstraction kit, signer signature pair. And then I'll define the signer signature pair as our type right here, signer signature pair. And the type is essentially a signer, which is our public key, WebAuthn public key that we defined already. And our signature is our WebAuthn signature that we extracted earlier from our get credentials. And then once I do user operation dot signature, I can now add it in. I can do safe account dot format IP712 signature to user operation signature. Quite a long name of function, but it does what its name. And then we're gonna pass it in the signer pair right here as an array, because you can also sign in with different with winners. So we're gonna pass it in as an array right here. And one thing that is important in this function is that you need to actually pass it in if it's an account deployment or not. So we're gonna do is init, which specify if it's an account deployment. We know this is the first transaction, but since if we don't know, we specify the user operation dot nonce is equal to 0n. If it's 0, then it's going to be true. Then is init is true. Then this is an account deployment. And I made one small mistake. Actually, format EIP 712 signature to user operation. It's not this function that we need. We need format user signature to user operation signature. That's the one we need. The other one we don't need in this one. Now we have added the signature to the user operation. The last step is actually to submit the userOp through send userOp. So I'll call in send userOp response, await smart account dot send user operation. It takes user operation and it takes a bundler URL. And now we just need to see if it was included or not. So we monitor the transaction. And then I'll do await send userOp response, include it. And if it's going to be included, it's going to return the receipt. So let's just console log the receipt. And that's it. Now we can run our transaction. This whole file essentially emulates what's going on with the WebAuthn and safe account, and it's secured by passkey. So let's run this example again. Cool, the transaction was submitted. We actually got a result and a full receipt here. We have the userOp hash, we have the entry point, we have a sender right here, and we should have also a transaction hash right here that we can copy, and then we can go see on the block explorer how it looks. So I'll go to Sepolia Etherscan, I'll search for the transaction hash, and you can see here I did a handle ops, which is the function of the entry point. I deployed the account, I used the paymaster, because I can see here there's a paymaster data. The one thing we could actually check is the owner of that safe. So let's go check it out. If I go into the center address here, I go in on contract. I know it's a proxy, so I'll have to read the contract as a proxy because it's a safe proxy. So very quickly, is this a proxy? Verify, save, go back to the address, read that proxy, and now let's call get owner query, and then we have an owner right here. It's an address. Let's look it up. What is that address? And that address is actually, you can see there's a bytecode deployed. This is the WebAuthn module, or the WebAuthn verifier that verifies the transaction from the passkey. It's not the typical owner. Let's also check very quickly the threshold of this safe. Should be 1. Correct. Now let's say you want to add passkeys as a second method of authentication. So how do you do this? So let's go back to our example right here, and then we'll deploy a second one, but this time instead of having a safe with a threshold of 1 only with the passkeys, we'll do it through 1 EOA and 1 passkey. And let's do this. So in my initialization function, I'll pass in threshold equal 1, and not in the array actually, but outside right here in the second parameter. And instead of just passing a WebAuthn public key, I'll also pass in an EOA public key. And how do I get the EOA public key? Well, let's define a new regular EOA wallet, new wallet from Ethers, and we're actually going to do create random, doesn't take the new, and then we'll get the public key of that EOA signer.address. And now I just initialized a safe with 2 owners, one with the WebAuthn public key and one with an EOA public key, and that way you have backup. If in case you don't have your passkeys, you could use the EOA initiate through that safe. If you actually needed it as a 2FA process, then you can have a threshold of 2, and that way you actually need to sign with both the passkeys and the EOA address. Now let's run our first transaction first with a threshold of 1 with the passkey and see what we're gonna get. Now we have submitted transaction. Notice that we actually created a completely new passkey, then a completely new safe, but instead of having just 1 owner, it's actually have 2 owners. I'm not gonna go verify this on-chain. You probably can do this. Since we already did this, we're gonna still do the same process again. Now I want to show you how you can do a 2FA. So instead of having a threshold 1, you can have a threshold 2. But now we need to sign with both the EOA and the WebAuthn. So we're gonna go down right here, and instead of passing a single signature pair, the signer signature pair only with the WebAuthn, we're also gonna pass it in and make it sign with the EOA. So let's do this. So we'll rename this the WebAuthn signer pair signature, and then we need to also sign with the EOA. So let's do this. EOA signing. So we're gonna get our signer. So with Ethers, you just do signing key. There's a function called signing key, and then you sign over the userOp hash that we actually also got initially. and we call the function serialize, the method serialize. And that way we have our signature with the EOA. We'll also need to construct it similarly as a signer pair. So we're gonna call this EOA signer pair, signer signature pair. And our signer is our signer.address, and our signature is this one. Actually, not a very good name, but let's call it EOA signature. Now that's a better name. And now we pass it in EOA signer signature pair in our array right here. And now we can execute it. So this script is going to execute or deploy a safe with 2 owners, threshold 2 out of 2, and we need both signatures of the passkey and EOA to actually execute this transaction. So let's try it out. And here we go. We executed it, and we have a safe secured by both an EOA and a passkey. And you can go in and we can look up this transaction hash. You will see essentially the threshold is 2. And then there's 2 owners, one the EOA and the other is the passkey. Another thing you can consider is gas savings. Since verifying the R1 curve takes a lot of gas on chain, there have been a proposal called RIP 7212, which brings the precompiled contracts not on the solidity level but deep down on the EVM level. And that way several rollups actually leverage this standard, including Polygon optimism. And if you want to leverage the gas savings on these particular chains, you can adjust your parameters in the safe, so you can leverage these because the contracts also takes care of this. So in your initialization function, there's a parameter called precompile E712 WebAuthn precompile verifier for shared signer, and that's a long name, but it's worth it. And you just need to add in the address of the precompile. Usually, same address. They are defined it on each chain. You just need to be careful if they adopted the same address. Optimism, you can go on the OP Stack website. I'll do it right here. Optimism, and then this is the P256 verify address. You just copy it. We can copy it right here, and that way during initialization you can make sure you're using some gas savings. And then during your create userOp, you need to pass it in the parameter for the compile, and you pass it in the same address as well. Also, during formatting the signature to user operation signature, you pass it in also right here. And that's pretty much it. Now let's try to execute this transaction again and then see what we're gonna get. Okay, one thing I didn't specify, we're actually running on Sepolia. Sepolia doesn't have the RIP right now, so it's not going to be using the precompile. We need to submit this transaction on a chain like OP Sepolia or Polygon testnet. They both support it. So let me change quickly the env variables to submit this transaction on OP Sepolia. Now that I've changed all my envs to OP Sepolia, I'm going to try to submit the transaction. Here you go. Now I submitted the transaction. I got the transaction hash. This transaction is going to have massive gas saving costs, and that's how you leverage the compiles. I hope you enjoyed the video. This was Passkeys. We reviewed a bit how you can build it with smart wallets, how you can leverage a 2FA system or as a backup as a signer with an EOA, and we also showed you how you can use the precompiles to save on gas costs on the chains that supports the RIP 7212. Thanks a lot.